Hi everyone. Today we're going to go over lesson 4.3 over ASA and SAS congruence. So today what we're going to do is we're going to find two ways that we can prove triangles are congruent with each other. But we're only going to prove three things. Now when you look at a triangle, technically there are three angles and three sides. So there are 6 things on each triangle. But we're not going to prove all 6 things. We're only going to prove 3 things. And we're going to prove them in a certain order that will guarantee the triangles will be the same size and the same shape, which is kind of neat. Now, the first one is called postulate 5. And for sake of ease, I never call it postulate 5. I just call it the ASA postulate or just ASA. And what it says is, it's quite wordy, but I'll explain it to you. If 2 angles in the included side of one triangle are equal to the 2 angles in the included side of the other triangle, then the 2 triangles are congruent. Okay, so included means in between. So you have 2 angles in the side that is directly in between them, which is different than if it's not included. Not included would be either this side here or this side. So there is a difference. The wording really does matter. So when you look at this, the other one, you have this angle, the side, and the angle. Now this angle is marked differently than this other angle, so they are different measures. If you have a situation like this where you have the angle, the side, and the side is directly in between, we can say these are congruent by ASA. And we're going to write a congruency statement. Now, the guy that wrote your textbook, he only uses congruency statements one time in the entire textbook, and that is here when you write congruency statements. Now, when you do the first triangle, you can put them in any order. I can say ABC, CBA, BAC. The order doesn't matter. You get to choose that. And I'm just going to do ABC. Now, the order of the second triangle does matter. So it's all dependent on the first triangle. So remember how we did corresponding points and corresponding angles and segments in the previous lesson? So we need to say what corresponds to A. And so since we know A has this marking, let's look at this figure, and it corresponds with F. B doesn't have any markings, and so that corresponds with E. And C corresponds with D. So again, order matters, especially of the second one. Okay, the first one, you determine the order. Okay, so I hope that all makes sense. So again, this is ASA. Now, again, Harold, the guy who wrote your book, he didn't teach you all the ways to prove triangles congruent in one lesson. There are 5 ways, and he spreads this out between different chapters. And just note, for now, we're just learning 2 of the 5 ways that we're going to prove triangles congruent. The next one is called postulate 6. Again, I don't call it postulate 6. I just call it the SAS or ASA. Now let's read it. It says 2 sides in the included, which means in between angle of one triangle, are equal to the 2 sides included in between angle of the other triangle. Then the 2 triangles are congruent. So we have 2 sets of sides in the angle that's directly in between. Okay, that's the same situation over here. We have the same markings in the angle that's in between. So you have the side and the angle that's in the middle. And so this is a case of side angle side. Again, your congruency statement. Pick a triangle. It doesn't matter which one you pick in the beginning. Just pick a triangle and put it in any order that you like. So I'm going to say HGI. And then I'm going to look at the second triangle and say, okay, what corresponds with H? And that would be C. what corresponds with G, and that's A, and I with B. Again, order matters. Remember, this actually tells you 6 things, right? Do you remember how we did this? Angle H corresponds with angle C, angle G corresponds with angle A, angle I corresponds with angle B, and we could do segments. HG corresponds with CA, GI with AB, and HI with CB. All right. Now, I'll be quiet for a second. I want you to look through these. They're all a little different. You need to find the pair that is congruent by SAS. So you're looking for 2 sides and the angle in between. So if you need to pause me, pause and try to find it on your own. Okay, so hopefully you have found it. If you haven't, again, pause me and come back. Here you have 2 sides, but if you notice the angle is not in between, the angle should be here. And you have 2 sides, but the angle is not in between, so I know it's not pair 1. So here I have 2 sides, but the angle is not in between. I have 2 sides, and the angle is not in between. So again, I know it's not this one. You have 2 sides, the angle between, 2 sides, the angle between, not this one. Here I have 2 sides, but I have the angle in between. That's exactly what I was looking for. 2 sides and the angle in between. So pair 4 is the answer. All right, same deal here. Go ahead and pause me, see if you can find the set that is congruent by ASA. Okay, so again, we're looking for 2 angles with a side that's in between them. So we have the 2 angles, but the side should be here, and it's not. So we know this doesn't work. We have the 2 angles, and the side should be in between. Doesn't work. With the 2 angles, the side should be in between. Doesn't work. And then lastly, the 2 angles, and it has the side in between. So it was pair 4 again. Okay, now sometimes our figures have what I call hidden information. Now, when I say hidden information, we're looking for a reflexive side. Now, what that means is that there's a side that both triangles share. And so like that segment, it doesn't change, size from when it's part of the first triangle is when it's part of the second triangle. And we'll talk about that more here in a minute. And we also have vertical angles. Now, these things are never marked. It's something that you have to mark on your own. And so you have to see it. Now, remember, we need 3 pieces of information. Now, this hidden information, this only works when the triangles are touching somewhere, okay? Triangles must be touching. So, come on, pen. Triangles must, my pen does not want to work, touching. Okay, now, let's just call this number 1. They're touching, okay? Right here, I'm going to label this so it's easier to talk about. AC. The length of AC is the top for the top triangle as the same length as it is for the bottom triangle. It doesn't change sizes. So remember when we learned properties, AC is equal to AC? This is the reflexive property. So whenever you have this, we can just go ahead and mark it. Now we have an angle, and we have an angle, and we have the side in between. And we have the exact same thing on the bottom, an angle, and the side in between. So this is a case of angle, side, angle. Now let's scoot over to this next one. It's called number 2. Again, they are touching technically right here. I see a pair of vertical angles. Now notice I didn't just put a little line here. I put an additional line on it so it looks different from this angle over here in the corner. And let's just go ahead and label these so it's easier to talk about. I know angle C and angle E are different measures, so I want them to look different. Now, Do you have three pieces of information? And yes, we do. So we have an angle, and we have a side. And we have the same thing over here. You have to make sure both triangles have the same information. And so we have a case of angle, side, angle again. Now, let's call this one number 3. They're not touching. So if they're not touching, there's never hidden information for you to add. So when you look at it and there's only 2 pieces of information provided, you have to say, well, I need 3 pieces. I have an angle and I have a side. There's no way to find vertical angles if they're not touching. And there's no way to find a reflexive side if they're not touching. So can you prove these congruent by SAS or ASA? No, you can't. These are not congruent. Doesn't work. All right, so number 4. They are touching. So what do we have hidden here? Well, we have vertical angles again. So we have an angle, and we have a side, and we have the exact same thing up here. And so again, we have a case of angle, side, angle. So we had a lot of angle, side, angles on that one. All right, can you prove these triangles congruent by ASA or SAS? Okay, now we have 2 sides and the angle in between. So why is this wrong? Because we didn't even check the second triangle. That's why it's wrong. Now let's check it. So you have 2 sides. Ooh, this is the angle that should be here. This angle needs to be included. Let's use our math vocabulary. It's in the wrong location. So this one's in the wrong place. Okay, so before you think of this, yes, sometimes this spells a bad word, ASS. And it just happens to be the ASS, angle, side, never works. That's just a coincidence. So if you ever have a problem and you're like, ASS or SSA, guys, they're all, let's just call it donkey. It doesn't spell a math word, it spells donkey. So we're not, donkey never works. So just put that out there. So can you prove this one? No, because this one's in the wrong place. So these are not congruent. All right, so now this next one is written more like a proof. We're going to take the information and kind of insert it into the diagram. Let's find angle BAC. BAC. So it's up here, and DEC is down here. Now bisect means it cuts it, right? So BD is doing the cutting. So BD is like the scissors, and it cuts AE. So AE is here, so it cuts it into 2 equal pieces. So that's what we have so far, but that's only 2 pieces of information. So then you have to ask yourself, do you have vertical angles or a reflexive side? And we do. Again, a common mistake is to do this. And that's confusing because all the angles kind of look the same. So we're going to put an additional marking on here to show that it's different. So this is a case of angle, with a side in between. Is it the same on the other one? Angle, side in between. So this is angle, side, angle. Perfect. All right. Next, state what additional information is required to know the triangles are congruent for the given reason. Okay, so there's going to be there's going to be hidden information. So they provide you one angle, and they provide you technically this hidden side. So we have an angle and a side. Now, this one's on a separate triangle, okay? So we can't just say angle, side, angle, because, first of all, that's not even the goal of this. Let's focus in on this red triangle, okay? So I want to get rid of that line. How do I make this triangle SAS? I need 2 sides. So I have two choices. I could either pick this side here, let's call this 1, or I could pick this side here and call this 2. I need one of them that makes it SAS. Remember, the angle has to be in between them. So here, like these two come together, it doesn't make an angle. So that can't be right. So let's get rid of that. If I pick this one here, I have a side and I have a side and the angle's directly in between. See how that works? So I know that has to be correct. Now, so I need XK. I need to do the other triangle. So let's focus in on this triangle. Ooh, that was a bad tracing. Let's look at this triangle. Still a bad tracing. We're going to go with it. So I have an angle and I have this side. Where should the other side go? Again, you have a choice of here or here. It needs to be where the angle is in between. So if my angle is here, I have to use this side right here. Okay, so the name of this side is WV. Now, we're going to use an equal symbol. The only thing that we use congruent on is the congruency statement, and that's when you write out the name of the triangle. So I know this is a little bit more difficult. Just try to stay with me. I'll keep explaining the best that I can. Okay, I need angle, side angle. Now, first of all, I see hidden information. This is hidden. I see some angles here, so I have an angle, I have a side, and I just need one more angle. And guys, you have just two choices. It's either angle U here or angle D. Remember, this side has to be in between. So angle, side, angle, it can't be D. So I need angle U. Now, this causes confusion. If I'm looking at this triangle here, I understand there's only a U, but if you look at this big diagram, I need to use 3 letters. So this is D-U-T or T-U-D. Okay, second triangle. Down at the bottom, I have an angle, I have this side, I need another angle, and that's this right here. Let's use 3 letters, S-U-T or T-U-S. It's your choice. So this is what you would need to make ASA work. ASA. All right, next one. We need side angle side. So we have a side here. You have an angle. They're not touching, so there's nothing hidden. And so we just need one more side. And again, you have 2 choices, this one or this one, the right or the left. And this time it's going to be the right one because you need the angle to be directly in between. So the answer is AC or CA. And again, side angle and then side. So that's LJ. Side angle side again. Okay, so they're not touching. There's nothing hidden. I have a side. I have an angle. And so I need the side that's directly next to it. I have a side. I have an angle. I need the side that directly is next to it. So this is JI and TS. All right, last slide. State what additional information is required to show the triangles are congruent. Okay, let's do ASA. Angle, side, and then this angle here. So this is angle L. I don't have to use 3 letters this time since they're not touching and there's no confusion. Now we have angle, side, and then I'm going to need this angle here, so which is angle T. Now this picture always reminds me of a butterfly. I have hidden information here, guys, because there's only one thing listed. Do you guys see these big vertical angles here? We know they're congruent. I need side, angle, side. So I have a side. I have the angle. So I have two choices for the side. And hopefully you're saying you need this bottom one. So you have side, angle, side. Side, angle, side. WV and VM. All right, so this is all your assignment is today. Next class, we are going to start doing flow proofs. And when I made that video, my pen wasn't working and it kept crashing. So I apologize in advance. Join a help session if you need any help. And I'll see you guys soon. Bye.